Okay, now let us have a better idea on how to sketch tangent function using example 1, where we have function fx equals to 3 times tangent pi over 4 minus x. So in here, I will begin with the calculations of the phase shift, where I would like to have the bracket terms here, make it equal to 0. So this will give me the answer x equals to pi over 4. So later, the cycle will start at the point of x equals to pi over 4. Next, I would like to find out what is the periods for one cycle to complete. So I will have again pi over modulus m, where m is corresponding to coefficient of x here. And once again, I want to remind you, for the case of tangent, the periods is calculated using pi. Just pi, not 2 pi. Next, by calculations here now, we can see that one cycle is complete in pi according to the info that we have. M equals to -1, substitute inside. The result period is pi. Follow, I would like to find out what is the subinterval width, where I have period divided by 4. So in here, I will have the common difference, pi over 4, for the constructions of table later. Okay. Difference from what we do in sine and also cos. For the case of tangent, I need to find one extra things here, which is what we call as the vertical asymptote. Before I go on with the construction of table, this is important to take notes. So we'll begin the calculation of vertical asymptote by having the bracket terms here, the mx plus c terms here, equals to pi over 2. And then from there, we solve the corresponding x value. So we have pi over 4 minus x equals to pi over 2. So from there, we have x equals to -pi over 4. So this is one of the vertical asymptote that we have in the tangent. If let's say we need to have more vertical asymptote, because as the graph is being extended, we have more vertical asymptote. And how we find the rest of the vertical asymptote, use this as a foundation, is that the key that we know from introduction just now is that we have our value here obtained plus minus with n times of the periods, which is, in this case here, the periods we have is pi. So I will have plus pi on it, plus 2 pi on it, plus 3 pi on it, or minus pi on it, minus 3 pi on it, so on and so forth. That will be the rest of the vertical asymptote. And as you can see, initially we get -pi over 4, we put in the middle. The next one to the right, it will happen to be taking the period that we find, pi, we plus on it. Towards the left, we will have taking the period, minus on it. So this is the clue that how we get the vertical asymptote, if we need more vertical asymptote as reference later in our calculations. So after the calculation of vertical asymptote, then only we consider the construction of the table. So with this information that I have, the phase shift equals to pi over 4, period is pi, subinterval pi over 4 as well. Vertical asymptote, as stated in this formula here with the list of result here. Now we construct the table of one cycle. So for the table of one cycle, again, I will begin with the x value, pi over 4, from the phase shift. Then the next value, we will add on with the subinterval width. So I have pi over 2 for the next value, follow 3 pi over 4, follow pi, and at last 5 pi over 4. So these are the x value we want to use as reference for one cycle. And then in here, I want you to be aware how the value is being inserted for this case here. So first of all, I would like you to alert here that the value here, 3 pi over 4, is actually what we have for the vertical asymptote. By right, this part here, we shall not have any answer if we try to calculate using calculator. So therefore, I want to make a remark here. This is where we have for the case of the vertical asymptote. And the rest of the parts, we can get the answer, calculate accordingly. So we have 0, -3. This is vertical asymptote, 3, and 0. So this is what we have for our table constructed. Then next, make use of this value here for the x and the corresponding reference value of the fx, we go for the plotting for the graph. So I will begin with the x-axis value. So I will have it start from pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4. And then we put in our y-axis. We put in our y-axis with the corresponding reference value, -3 and also 3. Then next, we plot in the point accordingly. So the first pair, I will have it pi over 4 and 0. Second, I have it as pi over 2, -3. Follow, I have the vertical asymptote. I have pi and 3, 5 pi over 4 and 0. So reach up to here, we can start to sketch our graph, and I want you to be aware, when the time you sketch the graph, this 2 point here is actually the reference for us to know that when the time our graph approach to asymptote, whether will it approach to positive or negative infinity, to upwards or to downwards, to positive or negative infinities. And these 2 points here is just for reference, and later we're going to eliminate it, erase it from the trace. And we don't even left the sub-interval in our graph sketching later. So now we go on with our graph sketching. So this is what we have for the graph. And now let us erase the unnecessary plotting there in our graph. So therefore, this is the result that we have. And also, as I mentioned just now, the pi over 2 and pi in this case here, which give the value -3 and 3, is just a guideline for us to know that our graph approach to positive or negative infinity only. So the plotting on the x-axis, we shall erase it as well. And therefore, this is the graph that we should have for the case of one cycle. For this function, 3 times tangent pi over 4 minus x. Next, of course, not all the time they will ask the answer for this form here. They may give us a specific interval for the domain. So for example, if let's say I would like to have the case of all real number, and let's say this is the size of the x-axis that I have drawn. So the coverage for the graph will be all the part that I have highlighted in green here. So how am I going to continue for the sketching? Similar like previous case, where I will continue plotting the needed point on the x-axis. And in here, please be aware, I'm no longer using the sub-interval from the calculation just now, but I need to figure out now for each of these part here, what happens to be the common difference. And we can see from here, we have a common difference of, I need to have it plus pi over 2 for moving to the right hand side, and the other side, I will have it minus pi over 2. So as a result, these are the points that I need for the x-axis. And then continue, we will have the graph sketching as follow. So this is how we complete for the case of if we are asking to find out what is the answer for the graph for all real number. And in here, please take notes on one thing here, where the asymptote, initially we have the reference as 3 pi over 4, and then the next asymptote, we find out that we have the value obtained by adding one periods of this graph here, one period of these functions of this graph here, which is pi just now. So the next asymptote will be plus pi to the right, minus pi to the left, minus 2 pi for the further left, so on and so forth. Okay, next. Let's say now I have another domain from 0 to 2 pi. How should we get the answer here? So again, we use this one cycle graph here as a foundations, and let us try to find out for the case of 2 pi, it is actually reach until where? So by right, if I continue to expand, go for the right side, from pi over 4, 5 pi over 4, go further for the next plotting, I suppose I will have it as 7 pi over 4 reached until here. It is still not yet reached the value of 2 pi. So if I go for the next plotting accordingly, by right, I should have the result as 9 pi over 4, which already exceed 2 pi. And 2 pi will be somewhere in the middle here. And now I can identify what is the regions that I need to cover for my graph, which is this part that I have it shaded in green. And next, I will go on with extend the graph accordingly to complete the answer here. And in here, beside 3 pi over 4 as a vertical asymptote, I will have another vertical asymptote at the position of 7 pi over 4, where in this case here, how I get this answer, I will have 3 over 4 pi plus with 1 period. And in this case here, the 1 period that I have, it is actually equivalent to pi. It is equivalent to the value of pi. And therefore, we complete our graph. This is how it should look like for the case of x from 0 until 2 pi, which is 0 until 360 degrees.